Yeah, awesome. Thank you very much, Mike. Welcome everybody. As Mike says, my name is Salman Iqbal, and I'm a trainer with LearnK8. And today I'm going to talk to you about namespaces in Kubernetes. It might seem like I created this title using ChatGPT, but rest assured I didn't. It's a bit long, but we'll talk about how namespaces actually offer no isolation and how you can use namespaces to perhaps have multi-tenancy and run multiple workloads inside it. But let's get started, right? So as I said, my name is Salman Iqbal, and I work as an MLOps engineer and like a DevOps engineer. I've been with LearnK8 for a little while. I've been doing Kubernetes training, and I've been also implementing Kubernetes stuff. So I'm a developer. I have a developing background. You can find me on Twitter at Salman Iqbal, only because I couldn't get Salman Iqbal, so I just picked Salman Iqbal. I should actually change the logo from the old Twitter to the X one, but you know what I mean. And I'm also on YouTube. I haven't uploaded many videos yet, but I do have a YouTube channel, so you can check out some small video clips. Well, I'll be uploading more soon, so you can just check me on, check out on YouTube, Salman Iqbal. Before I start, I want to say massive thanks to Loft. Really, thank you for having us. Thank you for having LearnK8. And we are going to be doing another session next week. So we had one, I don't know if you tuned into a session last week, which Daniela did. So thanks to Loft for having us, for doing these sessions. It's exciting, and it's fun to do these. Also, before I start, I want to say thanks to Daniela Polencic, who helped me put this presentation together. And we had a lot of discussions about what we're going to include. And he also did the first session, if you missed, around multi-tenancy. Just check out his session. It's on the YouTube channel and the Loft's YouTube channel. You can check that out. And Mike is going to share the link for the next week's session, which Chris Nesbitt-Smith is going to do. And I'll talk about that in the end, just to remind you about how to create a Kubernetes platform and what the tools and techniques you need. Yeah, Chris Nesbitt-Smith is very experienced, and he has done a lot of work on this. So yeah, it'll be good. So why don't we start with a catchy statement? Namespaces are not real. That's what I'm going to say. People sometimes start with clickbaits, but this is what I'm saying. But when I say namespaces are not real, what I mean is they don't actually exist in the infrastructure. You could think of namespaces, Kubernetes namespace I'm talking about, as labels that you can use to group resources when you want to list them. So they're not real. Then you might ask yourself, then what is real? Because you do actually deploy this into the cluster. It does exist. I promise this is the only matrix reference I'm going to do in this presentation, but you might think to yourself, what is real? But here you go. The point for this presentation is I'm going to take you through a journey of creating resources in Kubernetes. And we are going to look at all these different components. What about resources? How does it interact with namespaces? How does it work? Does it give us some isolation? Because most of the times when I'm talking to people, we do some training for Kubernetes. We LearnK8, we do training for Kubernetes. Check us out as well, learnk8.io. And people usually ask us, if I create a namespace, does it give me isolation? And the answer is not out of the box. So we're going to look at how does it impact these namespaces? How do they work with resources? When I say resources, I mean pods mainly, services and ingresses. How do they work? And also networking. Do namespaces come into play with networking? How does it work when you schedule pods? Is it aware of namespaces? And also I'll talk about permissions. And then we'll talk about how you can work around these issues around making sure we can work in a multi-tenant environment. What I mean by multi-tenant environment, how can I run multiple applications that belong to different teams in the cluster without impacting the others? But anyway, before I go into it, I'm just going to do a quick recap on Kubernetes. This is a really quick one just to make sure we're all on the same page. By the way, if you have any questions, please put them in the chat. Any discussions, just put them in. At the end of it, Mike and I are going to go through it and answer all your questions. So Kubernetes embraces the idea that we'll treat all the servers as a single unit, and it abstracts away how individual computers operate. So imagine you have a bunch of servers. It could be, I've got 3 in here. You could have more than 3. What you do is you install Kubernetes on one of those. That's the Kubernetes control plane. And then the rest of them become the worker nodes. And then you can take your containerized workloads and you can start deploying them using deployment files and pods or whatever it is. To us, it seems like when we're dealing with Kubernetes, we submit the request, it goes in and deploys all the pods in the cluster. So pods, i.e. containers inside the pods also, they go and get deployed in the cluster. What's actually happening is, even though it appears as one machine, what Kubernetes does, it does all the hard work for us. It takes all the workloads and actually figures out which node it should go on and places them on that workload. What about these workloads then? How do we usually deploy these workloads? Well, we usually create workloads. When I talk about workloads, I'm talking about pods. Right? Those are the bits that are doing the actual work, right? This is where your application's actually running. And the other resources as well. Of course, you might need a service, you might need a config map, you might need an ingress, all those things, you might need secrets, all of those things. But let's just focus on your applications, your pods, right? Usually, you don't really just deploy your pods just like that. You might create what's known as a namespace. A namespace is a Kubernetes resource that gives us a mechanism for grouping resources together. And that's that. For example, you might have 3 applications that you might want to run in the cluster. And these 3 apps could be anything. They could be belonging to different teams. And in this case, they're just some website. So what you might do is you might deploy one application in its namespace, because you might say this namespace is red, so the red app goes in here. This namespace is yellow, the yellow app goes in here, and all the resources for that go in here. But what is a namespace though? Basically, as I said in the beginning, namespaces is a logical partition of the cluster. Well, all we're using is to group Kubernetes objects together. And sometimes when you might read online, you might come across it provides isolation. It doesn't provide isolation out of the box. It's just a convenient way to categorize and compartmentalize objects. So this idea of that you can split your cluster up and you can have multiple tenants in the cluster, as in multiple teams or multiple user bases in the cluster, and nobody can see each other, is you don't get that out of the box, right? So namespaces don't offer any isolation. So how do I create a namespace, right? You can imagine you have a Kubernetes cluster. You can write a config file, in this case, YAML file. I'm showing you there. You can take this YAML file, you can submit that to the cluster, kubectl apply -f namespace.yaml, and then the API server receives the request and stores it inside the etcd. Usually when this happens, something might pick it up, and like, let's say you're deploying a pod, controller will come into play, and we'll say, okay, you need to deploy pod and scheduler, and it'll actually go ahead and create a pod in etcd, and then the kubelet will pick it up and actually create that pod. So a physical thing will get created. But what about namespaces? What does actually happen? What gets created in a namespace? So as I said before, namespace is not a physical entity. It's just a virtual construct used to isolate and organize things. And, it works by, you can think of them as labels. It's essentially you acting as a logical partition. So I've deployed this namespace, this yellow namespace, right? And I've got these 3 yellow pods that are running. And I can go ahead and I can create more namespaces and more deployments alongside them. So in this case, I have this green deployment and I have the green namespace, I have the blue deployment and the blue namespace. They're all residing next to each other. And as you can notice in one of the cases as well, they are also running on the same node. And all of these basically are residing next to each other. And we look at now, how does it impact in terms of networking? What can see what? Well, which we'll talk about in a second. But that's what we are so far. So fair enough, they live next to each other. But what does it mean when it comes to internal networking? And what do I mean by that? There are pods in a namespace, but in Kubernetes, the pods that live in the cluster can talk to each other. Doesn't matter which namespace they exist in, does not matter which pod they exist in. All pods can talk to each other. And that is because Kubernetes imposes 2 fundamental requirements for networking. Any pod can talk to any pod, and any node, any process that's running on the node can also talk to the pod. So you need to create a cluster with a networking configuration in which all pods can see each other. So let me just quickly show you how does it actually work. Let's say this is what my cluster looks like. I have 4 machines. There's no control plane in here, it's just worker nodes. I have 4 machines here, 4 nodes, worker nodes for Kubernetes cluster. And I have 1 pod, which is the red pod that's running on the leftmost node. And then I have the yellow one that's running on the rightmost node. Let's say the red pod wants to send a request to the yellow pod. A microservices architecture. Apps want to talk to each other. You would create a cluster in a way that all of these pods can reach each other. For example, in this case, the machines are on the same node, same network, but the pods are on the same network. So you might have at the bottom, as you can see, is a gateway. And the gateway might have a routing table that will say, okay, if your request is for like the yellow pod or whatever it is, send it to this node. Send the request if you don't know the IP address. This is the networking rule, right? If you don't know the IP address, send it to the gateway. The gateway receives the request, and then it says, okay, I know how to do this, and it forwards it to the pod. And now the red pod can talk to the yellow pod, even though they're in the separate nodes. So the point here is, the summary is, in terms of networking, networking is not aware of the namespace. So it's got nothing to do with that. But it doesn't end here, and we'll continue looking at some of the other bits. What about resources? Well, we already talked about resources. You already said that resources, they don't really care. Everything gets deployed wherever it wants to get deployed. They can run in different areas. It's all good. There's no limitation in terms of where it runs. How about scheduling? What is a scheduler? Well, the scheduler, I'm sure as you're aware, if you want to deploy a deployment, if you want to create a deployment with 2 replicas, and you create a YAML file and you submit it to the cluster, it receives the request, and the API server receives the request, and then the information gets written inside etcd. When it gets written inside etcd, the controller manager gets notified. The controller manager creates entries and puts these pods as pending. It's a deployment that we need to create. And then the next step is the scheduler. The scheduler needs to figure out where to place these pods. So the scheduler gets notified that now we have 2 pods which are in pending. So how does it actually then go ahead and deploy these pods? Well, there's a process of scheduling and binding. And in the scheduling phase, the scheduler itself has a queue in which all the pods get lined up. And then it has this filtering phase. And the filtering phase is just basically a bunch of checks it's doing. It's trying to see if there's a node that meets your requirement, or if it doesn't meet your requirement, it gets filtered out. For example, you want to deploy a pod with a GPU on. So it'll ignore all the nodes which don't have a GPU. But then you might end up in a situation where more than 1 nodes are suitable for this pod to run. So what it's going to do is going to score these nodes, the remaining nodes. And it has a bunch of criteria. It might favor the ones that's emptier than the other ones. It will give a ranking. And then eventually it'll basically bind it, and the pod will then be bounded to that node, and the scheduler is basically going to say, okay, this pod is now bounded, and then the kubelet will get notified, and the kubelet will create the pod. As you can see in all this thing that I've just discussed so far, the scheduler is not aware of the namespace. It doesn't care about the namespace. It just takes the request and deploys the pod. That's what it's doing. So far, we're not having much luck. But resources get deployed without, they're just running next to each other. So resources are not namespace aware. Networking, as we spoke about, is not namespace aware either. What about scheduling? Not namespace aware either. So it's all bad news so far, right? But we're not having much luck. So let's look at other things. By the way, I'm going to come back to these things and we'll see what we can do to make these things namespace aware. I don't know how you all doing. All good? Please do put in some stuff in the chat. If you have any questions, please feel free. I'm just making sure everybody's doing good. All good. Excellent. Any questions, just put in, right? Excellent. Very good. So far, we've just talked about these bits that are not namespace aware. What about permissions? So permissions, where do permissions come in? Let's say if I have a YAML file, I submit that to the cluster. It's a deployment, it's a service, it's an ingress, doesn't matter what it is. The request goes to the Kubernetes cluster control plane. And in the control plane, the API server receives the request, and that's what we always see. But API server is usually shown as a block, but there's actually, as you're aware, there's a lot going on inside the API server. The first thing that happens is authentication. So the authentication happens, it basically connects to an external system, an external identity provider, and you can configure whatever you want inside. You can connect that. The user then tries to submit a request, and if you're not authorized, if you're not authenticated, you just get rejected. So your request goes up. But if you do get authenticated, then your information gets taken. A user info object is created in which the username is added, the ID is added, a bunch of other information is added, and that gets passed on to the authorization component. So far, if I'm authenticated, so you can see we've got the user management system there, authenticated, and this gets passed on to the authorization system. And the point of the authorization system is you might be authenticated, but what you're about to do maybe you don't have the permissions for. So that's what the authorization is doing. Perhaps the authorization might be aware of this namespace. It might have some namespace awareness. So let's have a look at what happens in authorization. Again, just like everything else inside Kubernetes, we can drill down furthermore. So an authorization component is also modular, and you can have multiple authorization strategies. This one is out of the box. This is node authorization, is basically for API requests made by kubelet. There's another one called attribute-based access control. You give access based on particular attributes, maybe a role, maybe a department, maybe a group that belong to, just a bunch of attributes. That's what RBAC is. I'm sure you've heard about RBAC. This is what is usually enabled in most of the clusters, right? Role-based access control. Again, based on the role of the individual user, we can define some permissions. So that's one option. And the other one is the webhook option. So you can basically connect it to somewhere else as well. That, again, just some information there. So let's have a look at this RBAC option, right? So most of the clusters, if not all, you can, by the way, have more than one authorization plugin enabled if you wanted to. And the modules are checked in an order, and they can say, yeah, I don't have an opinion, I don't have an opinion. And if one has an opinion, either deny or allow, that's immediately used. But most of the, as I said, not all, but most of the Kubernetes cluster that I've come across have RBAC enabled by default. So what is RBAC? So let's have a look at that. RBAC, you can define roles. So roles, as you can see in here, on the top, I have the two tables. You can see the two tables. There's roles. On the left is what's known as a cluster-wide role. So it's a cluster role. And on the right is a role. And roles apply to namespaces. There you go. First thing that we talked about, a namespace, right? That one, it applies to a namespace. So let's have a look at how this works. And so on the left one, you can see there's admin one, has some roles, has read and write for pods, and the same thing in the other one. And what you can do is you can assign a role to a user by what's known as a binding. In this case, we can give a cluster role binding. Cluster roles and cluster role bindings are cluster-wide. And roles and role bindings are namespace specific. So there we are. First thing that we talked about, something that's namespace aware. So let's have a deeper look. I'm just going to quickly share a couple of files just so you're aware. I'm sure you've seen this. We have this YAML file in which we define the role. And the role you can see in here, I have the namespace. You can see down here, I have this namespace here, right? So the namespace has been, namespace has been included. And then we have the rules. And the rules say which API groups this rule applies to and what can you do. In this case, you can get and watch pods or deployments you can update and patch them. That's what a rule is. But this thing applies to a namespace. So first thing that we talked about is namespace. And just for completeness sake, a cluster role is just for not a namespace, right? So the namespace doesn't exist, just for completeness sake. So I include that in here. And also this is how you define a role. So we have a role in here. You can define the role and cluster role. So anyway, we talk about role and role binding. So this is a role now for a given namespace. And you can define that in this case, you can whatever the role might be. So far we have talked about a bunch of things. And the first thing is we said resources, well, not namespace aware, doesn't matter, it doesn't do anything. Networking, not namespace aware. Scheduling, not namespace aware, out of the box. Permissions, yes, if you define the roles and the role bindings, right? So cool. Now we're getting somewhere. Now we have some stuff. So let's see if we can build on this. Maybe namespaces are for resources too, right? Remember, I said this, the scheduler doesn't mind about namespaces. You can have as many pods as you want, and then you can use as many resources as you want. The scheduler doesn't care. To work around this issue, Kubernetes has two resources to restrict what you can deploy in a namespace. And these are resource quotas and limit ranges. And that's what we're going to look at. So here you go. This is what a resource quota looks like. This is the YAML file. Again, I'm trying to bring in things that are namespace aware. A resource quota defines the amount of resource that is made available in the current namespace. So you can, this is, by the way, it doesn't say namespace. That means you have to create, you actually deploy it in a namespace. And the requests value, so in here you have requests and you have limits. You can see there's a spec you define, there's hard pods, that means you can only run 10 pods in that namespace, right? Okay, cool. Now we're saying there's some stuff you can apply some limits to. And then that's for the pods. And when you set requests in here, this you can see the request CPU, and for CPU or memory, Kubernetes ensures that the containers within that namespace gets that amount of resource when it needs. And the limit value defines the maximum amount of resource that a container can consume. If a container tries to, let's say, within the namespace, right, it tries to exceed its resource limit, the system will start to, restrict those limits. For CPU, for example, start throttling. For memory, the container might get terminated if it exceeds the limit, right? So there you go. We have resource quotas that are namespace aware. So then you can start telling people, okay, you belong to this namespace, you can only do this much stuff. But how does it work? Let's see how it works. Let's say I take that resource quota and I submit that to the Kubernetes cluster and I deploy it. So now we can see that I have a limit set, and you can assume this is the size, right? So I've set this limit to this namespace, right? That's gone in. Resource quota has been set. Now, so I said earlier, scheduler is not aware of namespaces. So how does it decide what to implement? Who actually does this? The scheduler is not namespace aware. So when it tries to deploy a pod, it has no concept of this namespace. So how is it actually going to go ahead and deploy that? Well, the scheduler doesn't do anything actually here. This is where, in the API, there's a component called the admissions controller. That's where this check is actually happening. So the request, you remember in the beginning we talked about authentication and authorization. Then it goes to a bunch of admissions controller. And an admissions controller is broken into three parts. You have a mutation as admissions controller, you have schema validation, and you have validation as admissions controller. And as for mutations admissions control, the component, so each of these bits, mutation will come to the mutation admission control. Mutation admission control just looks at your request. When you do a kubectl run, name of the image, and you don't provide all the required bits, basically it just fills in and mutates your request. Validations admissions controller validates the request that you've submitted. Before it can go ahead and submit this is going in the API, right? So it needs to go ahead and get stored inside etcd. So anyway, goes to the validations admissions controller. Validations admission controller is a bunch of components inside. I'm not going to go through all of them, what the components are, but you have stuff around certificate approval. It just makes sure that the user, the approving user has permissions to approve the certificate, that kind of stuff, right? So certificate signing, there's a bunch of stuff on certificate. So limit ranger enforces limit ranges on a namespace. We'll talk about limit ranges in a second. And then you have the namespace cycle. This is where, when you try and create something in an object that doesn't exist, in a namespace that doesn't exist, this throws up. So this is where, it's aware of namespace. So that's not the one that I'm actually going to talk about. There's some volume stuff. This is the bit I want to talk about, resource quotas. This is where any incoming request that comes in, it ensures, the API ensures that you're not violating the requests and the limits that have been assigned by resource quota. And if you are, then it gets rejected. So this is the bit that we care about. In this case, you can notice that the validations admission controller has this resource quota. The plugin you use this is the plugin that's used to check that the resource in the current namespace meets the requirement of the resource quota. But there is a gotcha though. There is one gotcha. Hopefully that makes sense so far, right? So we can say that we can assign resource quotas. So within a namespace, people can just use the resources that we allocated to them, because you don't have unlimited amount of capacity in a cluster. So people might start using more. But there is one gotcha. The controller can only check resource quota if the pods that you're deploying has requests and limits. Now, every time you create a deployment, you can define in here. You can see in here, I have nothing apart from just the image and anything else that might be running. I do not at all mention what the requests and limits are. If I don't mention what the requests and limits are, as in how much the pod should be consuming, then basically this resource quotas don't work, because the kubelet will inform the control plane that here's the scheduler won't be able to figure out. Basically, what will happen is you'll say how much memory does this pod need. I don't know. You haven't defined it. You have not defined it. So how do I make sure that the quota is not exceeded? Because usually when you deploy in a cluster, you have to have, you can see in here, there's a diagram in here. You have to allocate some resources, some CPU and memory for other components that are running in the cluster, in the worker node. And if you don't define that, maybe your container will start to use more memory and CPU than what it is. And somebody in the chat, Muthu, has correctly guessed that this is where you need limit ranges. And then limit ranges is basically you can set some defaults to ensure that these are always set. So limit ranges, this is what it needs. You need to use resource quotas with limit ranges. So you need to define some defaults to ensure that they're always set. Those are also specified with limit ranges, objects like like you have the default. So it can set a default request and limit for CPU, or pods in the namespace that don't have explicit resource or request set. And it can enforce minimum maximum resources as well. So you have max and min. And you can also say what type of resource you're applying it on. Of course, there's other thing. You can also define a policy using Open Policy Agent, using Kyverno, using Kubewarden to reject a request that doesn't have those bits, right? So there's more things you can do. There's more things you can do. But anyway, that's that, right? And how does the limit ranger work? As I showed you in the diagram earlier on, this is the bit that looks at it and goes, okay, cool. These are the bits that are limit ranger is one of the components it checks in, says, this is where it's going to come in and mutate the changes in here. Now, we've been on this journey so far, right? So we said, well, resources are not namespace aware. Well, they are if we use the quotas and limit ranges, right? So this is maybe then what they are. Cool. So let's continue. Let's not stop. Let's keep going. I think there might be a couple of questions, but I will answer them in the end. I just want to make sure we get to the end because we're already halfway through the hour. So maybe namespaces are also for the network. Remember in the beginning, I said namespaces don't really care about the network, right? Because pods can talk to pods, which is good and also maybe bad because you're sharing a cluster amongst different teams. And if that's the case, you don't want one pod from one team to be able to see what's happening in another pod from another team. So every time I talk to people starting up with Kubernetes, there's this assumption that namespaces are probably segregating this network traffic. And then this is where you can use something called the network policy, right? So namespaces are a convenient way to group, but again, they don't do that. For example, I have these two namespaces. I have this default namespace, and I have an Nginx ingress namespace. So network policies are a Kubernetes native object that give you a chance to define rules for internal network. For example, you might want to control all the inbound or the outbound traffic for a namespace, right? That's what you might want to do. So this is where namespaces come in. So let's take a look at an example. An example is this. I have 3 pods that are running. And what I want to do is the auth pod to not be able to talk to the backend, but just the web pod can talk to the backend. That's what I want to do. And what you do is you define network policy. And a network policy, you can pick a target. You can either pick pods, which I'll show you in a second, and then you can define where you can have an ingress or egress from. You can define all of that. So for example, what kind of bits you can do. In network policies, you can define how a pod is allowed to communicate with the rest of the cluster using 3 identifiers. You can either use pods that are allowed to send or receive traffic, or you can enable or deny traffic from a namespace. There you are. Right? That's what we're looking for. We're looking for bits that are aware of the namespace. And this one is also aware of the namespace. Just for completeness sake, you can also add in for IP addresses, IP address ranges, but just for completeness sake, I'm adding it. So, but let's see how these policies are enforced, right? How does it actually work? So we said, well, actually, networking might be aware of the namespace, but how does it work? So here's how it actually works. Imagine you need to create a container. You're trying to create a pod inside the cluster. You submit a request to the control plane, and then the kubelet receives that request inside the worker node. And what the kubelet does, well, actually calls upon interfaces. So it needs to call upon an interface to create a container. It needs to call upon an interface that basically attaches the container to the network, assigns it an IP address, and does a bunch of other things, right? So run it, assign the network, attach it to the network, and also maybe you need to attach a volume. Bear with me. There you go. So these are 3 things that need to happen. So kubelet will call these three interfaces: the container runtime interface, the container network interface, and the container storage interface. At runtime, you can, this is what's known as CRI, CNI, or CSI. And, they could be anything. You could have like container D, cryo, whatever you want. That's the runtime. And Calico, Planner, whatever you want in terms of the network, overlay network, the CNI that you're calling. And this is where these network policies are implemented in the network overlay. The CNI implements those, or the volume as well, of course, CFFS. But how does it actually work? Who actually implements this, right? So let me just take you one step inside as well, just a little peek into how it works. Imagine this is my node, and I have the root network namespace. And then in the node, I also have a pod network namespace that connects to the root node namespace, because this is how I want to run multiple pods containers inside that in that node, right? So imagine this is like a machine with a Docker bridge on it or whatever it might be. And then you have an overlay network installed. What's actually happening is that network policy, what it does, because we said network is not aware of this namespaces, what network policy does, it writes additional firewall rules on every node using a daemon set. So the daemon set is a pod that runs in every node. So firewall rules, usually in IP tables or eBPF, it'll write a firewall rule. So the bit that's actually implementing this who can talk to what is these daemon sets. They're responsible for downloading the network policy and understanding the constraint, i.e., no traffic is allowed to escape from this current namespace. That's where it comes in. And then it translates those requirements into firewall rules. Usually, as I said, maybe IP table rules or eBPF. So it depends. So most CNIs, of course, support this network policies, and this is what it looks like, right? So they all download this. Every time you submit it to the cluster, it receives it and figures out and updates those rules on there. And then basically, this is what we have. We have new IP table rules every time we assign a new policy, network policy that gets allocated. Doesn't matter if it's for networking, for a namespace or pods, whatever. That's where it gets implemented. So going back to the question that we're asking, what else is namespace aware? Well, we said resources were. Networking is also. If we use network policies, right? If we don't use network policies, then it's not namespace aware. You can see there's work you need to do. In Kubernetes, it's not just about, I'm going to create a namespace, I'm going to create a pod, I'm going to create a service, I'm good to go. Well, not really. It depends on what you're trying to do. There's other bits you also have to set up. Cool. I think there's a couple of questions, but we'll answer them. Hope it's making sense. But let's continue with the journey. We're building up to where we want to get. I know you're probably thinking, give me the solution. What is the solution? And hopefully you can think of a couple. So let's get back to the point that I'm trying to make, right? Namespaces are not designed for, as you can see already, multi-tenancy. Oh, by the way, yes, that's a good shout. So network policy editor from is a good tool for you to figure out if you want to see the network policies. Anyway, so namespaces have nothing to do with network, right? But again, nothing to do with multi-tenancy. And it shows when you focus on shared Kubernetes components such as core DNS. Let's have a look at that. What is core DNS? Every time you create a service, you can think of inside a cluster. You can think of a service as internal load balancer. So if you have multiple replicas, how do you pick a replica to send the request to, right? So that's what a service is. So every time you create a service in the cluster, the name of the service is added to the in-cluster DNS. So if your name of the service is service.red, so the name of the service is, let's say, red, it'll be like red.namespace, the namespace that's in. So that bit is aware of the namespace, .svc.cluster.local, that's what it stands for. And if your pod is in the same namespace, you can just call it with red, and it'll basically pick a pod and send it to you. It'll respond back with an IP address of the pod. And if you're calling for a different namespace, you just have to give it the full name. But the DNS component is running the cluster, right? Core DNS is called. That's called core DNS. So when your pod wants to make a request to a service, let's say a headless service or cluster IP, all it has to do is use the name of it, right? So a headless service. So since the request is not an IP address, but a name, it's forwarded to core DNS. And core DNS usually, basically, will reply with an IP address of the component. Headless service doesn't have by the way, an IP address, but Core DNS is smart enough to give you an IP address of one of the pods. And then once you have the IP address, then you can start receiving the requests, right? So that's cool. That's fine. That's how it all works. But what can happen is, let's say these two pods are running in different namespaces. Nothing stops one pod in a tenant. So that actually not just a pod, the whole tenant. So tenant is a bunch of teams or users from overloading the DNS and affecting all other tenants inside, right? So again, so Core DNS is aware of namespaces because you can reach it, but it doesn't stop namespaces from saying, oh, you can't send this much, all these requests because others are getting blocked. So, Core is so single pod from the names. The others might not be able to send requests. You can stop that, actually. You can't do much from stopping other namespaces from sending requests, but you can define Core DNS policies. For example, this example shows how firewall could be used in a useful way in Kubernetes-based, multi-tenancy application. So basically, it uses this Kubernetes plugin. You can see, check it out on GitHub, Core DNS/policy. Or just type Core DNS policy, it will come up. It basically uses Kubernetes plugin metadata to prevent pods in certain namespaces from looking up services from other namespaces. And you can. This is one thing. So you can define those policies. So for example, in this case, something that starts with a tenant. Any of the pods that are in that namespace can send a request. That's one thing. And the other thing, and you can stop that from happening. And also you can stop things from a specific namespace sending too many requests. So for example, in this case, requests come to the API server, right? So they come into the API server, a bunch of requests coming from different tenants to the API server. And the API parses the requests and stores the objects in etcd, right? So it comes in, parses it. But anyway, the requests are coming via the API server. You might have a tenant, the one in yellow, that could start sending a lot of requests to the API server. And then this other pods might not be able to receive it, right? So they might not be able to receive all these requests. So in this case, things are a bit more complex. Kubernetes has a mechanism to prevent requests from overloading, right? So this is you can have max request in flight, but that's got nothing to do with the namespace. But the possibility is so real that in Kubernetes 1.29, it's still an alpha. There's a new feature in which you can mitigate against this, all the requests coming from namespaces. So you can set up like priority and fairness coming from namespaces. But this is an alpha, right? So this thing is namespace aware. But so what I've been saying, we're almost coming to an end, right? So we've been going on for a little while. So come again. What is the summary, right? What is the summary? So far, you've seen that namespaces aren't really for multi-tenancy unless you do a lot of work, right? We talked about all the work that you have to do. Network policies, you have to define the roles, you have to define the quotas, you have to define all of this stuff. And of course, just touching. And also, so there's nothing to do with multi-tenancy, nothing to do with isolation either, right? So we're not really isolating any workloads unless I go in and start defining network policies. Basically, what it is for is grouping, which there should be a checkbox. There should be a green tick there. I don't know why there's just a block that's appeared, but it's really just used for grouping. What if you wanted some proper isolation? How do I get this isolation, right? I want to be able to have a multi-tenant environment in which different teams can live in, and in the same cluster I can share. So if I wanted some stronger isolation, for example, namespaces could be an answer if you do all those works, but you might want some stronger isolation. And if that's the case, what you can do is you can be like, you know what, I can start giving addition out multiple clusters to multiple teams, right? So in that case, the control planes are isolated, the workloads are isolated, everything is isolated, right? So I can start dishing out all those clusters to different teams. If I do that, of course, there's a lot for me to manage, right? So because now you got like isolated control planes, different versions of control planes, and you have different teams, different environments. That's a lot to do, right? So this is not really gonna work out, right? So I mean, it can work out, of course, but there's a lot to manage. So far, I've just given you bad news and a lot more work, right? So well, there's not much. Multi-tenancy doesn't really give you much. You need to do a lot to set things up. What are other alternatives to this? What else can I see outside, which perhaps can give me the isolation that I'm after, so I can have multi-tenancy environment and people can live happily ever after in the cluster? And this is where, let me introduce to you a couple of options. One is You can have multiple clusters, of course, that's cool, but that's management heavy. But what if you can? What if you can use something called the vCluster from Loft? Shout out to Loft vCluster. You should check out that project. The way this works is you basically, it deploys when it has a CLI tool. You can use vCluster. Check it out, vcluster.com. You have a Kubernetes cluster, and the idea here is you can start to share a cluster between teams by creating multiple clusters inside. I know, Inception, but bear with me for a second. So what happens is when you install vCluster on your cluster, it actually runs a regular pod. It runs a pod. K3s is a lightweight. It's a lightweight, basically, lightweight Kubernetes offering, but it doesn't have any nodes. It doesn't actually have any nodes. So what happens is you can look at it, and this actually looks like a control plane, right? This looks like a control plane. There's an etcd in here. So what you do is you create these separate clusters inside your cluster, and then the teams get given access to this virtual cluster, hence the name vCluster, virtual cluster that's inside the cluster. They get given access to that. The admin has to go and configure it. So the end user doesn't know what's happening inside the cluster. They connect to the API server inside it. And then what happens is basically you submit the request and you deploy it to the cluster. Now what happens? You want to create a pod. How does it actually get created? You submit that to this pod. This receives the request. And what I need to do is this pod that's running inside, this pod, the vCluster pod that's running, the control plane, is not actually creating the pods. This stuff, the pod spec or whatever you're trying to create, gets copied into the actual Kubernetes cluster. The actual Kubernetes cluster then creates it for us. And how does it create this? Well, how does it actually sync that? There's a thing called a syncer that takes all this information and takes that and actually submits it to the control plane, and then it gets created inside the node, inside the namespace. Now, here's the bit. All the other bits that you have to do before, you have to come up with network policies, resource quota, limit ranges. All of that is taken care of by vCluster. Or you can also configure whatever you want. There's a lot of configuration options in there. So this is giving you some isolation that you don't have to, as an end user, don't have to worry about. You just say, here's my deployment, deploy it, because you only have access to that given cluster, which is in a namespace. And then the syncer takes the information, passes it on, and then it gets created. So this perhaps gives you a bit more than what you had before, right? So this is definitely check it out, vcluster.com. And I think Mike was mentioning there's going to be some, later on, there's going to be some sessions on this, some labs on hands-on labs on vCluster, so you can check that out. And Chris also, check out Chris's session next week. He's going to talk about this as well in more detail. I'm just going to mention one more thing for completeness sake. We're coming to an end. That's one option. The other option is you can have multiple clusters. If you have multiple clusters, management of those clusters is very hard. That's very tricky. You can't do that because, well, I mean, you can, but there's a lot of work you need to do. For example, if I have multiple clusters, how do I define which should go where? And this is why I'm going to mention this project called Karmada. Karmada, you can think of Karmada as like a management cluster for all the clusters that you have. And the way it works is you can basically, it spins up another cluster on top. You run a management cluster, and this is connected. This is aware of all the other clusters inside your, the clusters that you're trying to manage. And it runs an agent on each of those clusters. And every time you want to submit something, let's say you want to do a deployment to a specific set of clusters or whatever, you can define these policies. You can define all this management, and this can basically take that and figure out and deploy this on that cluster, on whatever the smaller cluster is. So I just wanted to put it in here, but it doesn't deal with traffic, by the way. So if you need to do cluster to cluster traffic, it doesn't do any of that. It's just management and deployment. If you want to look into just addition, but if you want to look into like traffic management between multi-clusters, then you have to look at something like a service mesh, which has a gateway that can do this. But anyway, this then goes ahead and creates you the pod that you need. Now, we're coming to an end, right? Everything, of course, has pros and cons. All the options that I talked to you about. The first one was all these bits that you have to create, and then we talked about vCluster, then we talked about Karmada as well. But all depends on what you are after, how much isolation you require. right? Depends on your use case, how much isolation you require, and how much management ease of management you need. Like maybe there's a lot you need to manage. I don't know how much capability you have to manage that. And also, you also need to take into account how much it's going to cost, of course. So I'm just going to put in a shout out to the vCluster folk. vCluster folk have this diagram on their page, vCluster.com, about what these are. Of course, there's separate namespaces, vCluster, separate clusters. Again, there's bits in here that explain you, but you have to look at everything. And everything has trade-offs. Depending on what your requirement is, you might have a separate namespace. But if you apply all these bits, you might still be okay. But that all depends on what your requirements are. So what are the takeaways, right? Let's just quickly talk about the takeaways. Then we can answer some questions, and then we can finish up. So namespaces do not mean isolation. Hopefully that's clear. That's what we're going to talk about for the whole session. But unless you do this extra work, unless you define network policies, unless you define limit ranges, unless you create roles and cluster roles and permissions and all of this stuff, right? But there's a lot of things you need to create for that. If you want a bit more than that, you can isolate the control planes. So this is where vCluster is going in. vCluster is saying, you know what? Why don't you have isolated control planes? So that means the control plane you have access to, you just submit a request, even though it's running in the same cluster, things will get created in isolation. So that all the hard work that you were doing before is already taken care of. Or you can go with dedicated clusters. It's entirely up to you. You can create multiple clusters depending on the requirement. But you just have to remember that everything you look at, every option has a trade-off. One thing is not better than other. Everything has a trade-off. What I would say is if you have trade-off, just choose your pill wisely, right? So I did say in the beginning, I won't make any matrix references, but I just had to put last one in. Choose your pill wisely if you're looking into it. So before I finish up, a couple of things. Next week, same time, next week, on the same day, building a self-serve. It's all about platform engineering nowadays, right? So how do you build this self-serve Kubernetes cluster from scratch? So the tools and the planning and the techniques. This is a cracker of a presentation. I've seen the demo. I've seen the talk. It is going to be awesome. You should definitely sign up for it. And also, if you have not checked out the previous one that Daniel did about multi-tenancy, you can check it out. It's on YouTube channel as well. I think Mike has shared the link, so definitely check it out. That's the link at the bottom. Thank you very much for listening. I hope that was beneficial. We'll take some questions in a second. But if you want to reach out to me, you can reach out to me on Twitter, Salman Iqbal, and also I have a YouTube channel, so you can check out like and subscribe, whatever people say nowadays. Also, do check us out, LearnCates. We are on learncase.io. We have a bunch of blogs and other things, and if you're interested in training, we can please do check it out. Also, thanks to Mike and his team at Loft for having us. It's great fun to talk about these things. So yeah, that's it. I'm gonna take a quick sip, Mike, and maybe we can start answering questions.
Yeah, that was great. That was a lot of information, and I learned a lot too as well. It was awesome.
All right, cool.
All right, you already did half my work for me. You say join us for the next session on the 14th. And then also we will send out an invite for a future workshop with hands-on labs and stuff for vCluster and everything if you're interested in that. And then yeah, join us on Slack, slack.loft.sh if you've got questions, and we don't get to all of them here. I think Chris has been helping out a little bit with some of the questions too. I don't know if he sent over to you with notes, but I'll go. I can
Okay.
read through them and start.
Yeah, go for it.
Okay, cool. I think this one got answered, but we'll ask it again because it was a good question, just in case you want to expand on it. So, how is the quota checked against the namespace? I thought we can limit stuff across. I thought we can limit stuff across the namespaces. How do limit ranges come into this? How do come into the effect that is usually defined at the namespace level for containers and pods?
So I think we talked about that. The API itself has a plugin that checks and then just applies that, so the request gets rejected at that level before it even goes to etcd. So I hope that got answered. I don't know if there's anything else I need to add to that.
They said you kind of answered it a little bit too on there too, so that's perfect. I don't know if you've got some stuff from Chris, but like I said, I'll go to the next one too. All right, so
yeah.
As far as I understand, main advantages of vCluster is isolation, which namespaces don't have by default, but by using network policies, we can achieve that. How is vCluster better from existing options to choose over? I can add one thing.
I was gonna add one thing, and I'll leave it open to you to add multiple things. I was just gonna add one thing, because I think one of the benefits that I see is if you have multiple clusters, you might have similar tools that you want to install. You want to install Prometheus, maybe you want to install Istio. That's what I see as a massive benefit. Now it's on to you, Mike, to add a
That's
bit
a
more.
That's a huge benefit. Yeah, being able to install the CRDs and stuff that you want to install. It's a different API endpoint, meaning that you're not giving users access to the base cluster. You're giving them their own cluster, so they don't have to have API access, like I said, to the base cluster. So you can split it up that way. So you can't really do that with network policies. You can also create a vCluster that's either isolated or open, so you can kind of use vCluster itself to manage the isolation for the configuration. Other advantages to go check out the docs and check out the videos and give it a try, and you'll probably find some stuff that maybe we weren't even thinking about. But yes, CRDs, isolation, API endpoint that's different, and then it's good for ephemeral, it's good for production and everything. All right, let me go to the next one.
Awesome.
Sorry, still waking up a little bit. It's early over here.
No, you do well. You do well.
All right, does vCluster sync only pods? What if I want to expose a control plane for the team that wants to run custom operators and configurations? Might include storage class definitions, network policies, and CRDs. I'll let you answer it first, and then I'll follow up with some.
I'll let you answer this one. I'll give it to
perfect.
you. You're doing an excellent job in answering this one.
Yeah, it's built for that, right? So if you want to have CRDs for each of your users that you don't want to manage on the base cluster, they can install CRDs there. You could also share CRDs from the base cluster up to them. So you could do something like syncing ingress, so that you don't have to have 50 ingress controllers running on a single cluster. You can just share that up, and their stuff will get synced. But that's kind of what it's for, right? Like, you decide what you want to share up. We've got a lot of built-in stuff that you can share with the generic syncer, and then we also have information on how you can add custom resources that maybe aren't covered by that, like crossplane and some of the other things. Okay, cool. So we have another question. So the new pod request talks to the real controller API, which then talks to the vCluster syncer to schedule the pod. So if you want to answer that. So
no, you carry on. Okay. You carry on.
So vCluster, like, we're still using Kubernetes under the hood for everything, right? Like, you've got a new API. It gets created in the new cluster, and then it gets synced to the base cluster, and then the base cluster still does the reconciliation and has the controller watching for that. So it'll create the resources itself. So everything's still getting created on the base cluster. It's not like a hypervisor where we're kind of we're just using Kubernetes on top of Kubernetes.
Yeah, it's just the control plane, the actual control plane is actually doing the work. And the end users just see this virtual cluster, the virtual control plane that's created. That's correct.
I think we had a question to expand on quotas too. So when you're showing the quota, you showed a quota of like 4 CPUs. What they're saying is that for each pod gets 4 CPUs, or all of them? I think when you're applying,
that's all of them, right? So it's the namespace. So everything in the namespace gets it, right? So whoever gets there first gets more, and then the rest of them they just starve. I guess that's the point I think they're trying to make.
So if you're doing a quota, make sure you don't just put 10 or 4 CPUs if you've got a group of like 10, 15 people in there.
Yeah. I mean, I've been, to be honest, I have been in that situation by mistake, of course, and it wasn't a good call to wake up to at night.
And then I think we had a question when you were showing off Karmada. Asking if it was related to Cappy, or if that was
Cappy. I don't know. Do you know of Cappy? What is Cappy? Cappy. Let me just see.
Cluster API. I think it's different, because I think what that does is it was scheduling on each of those clusters, whereas Cappy is like being able to like define and create a cluster.
Define and create clusters. API. Yeah, this is again. Yeah, sorry. Cluster API. Now I remember Cappy.
This is easier.
Yeah, that's it. Cluster API. That makes correct. So as Mike says, Cappy is Cluster API. It's the first time I started calling it Cappy. Cluster API is all about managing and defining your clusters, but this Karmada is about how do I deploy. Sorry, maybe I wasn't clear. How to deploy my workloads onto all these clusters that I now have. So like maybe there's a there's a cluster that's running in UK. There's a cluster that's running in America. How do I figure out I need to deploy some workloads? They should all only run in UK. So this is the bit where Karmada comes in and helps with managing that deployment. Because if you have multiple clusters, basically the idea is I have multiple clusters. I want to manage deployments to these clusters from one endpoint. Otherwise, I'm going back to the virtual machine world that you and I love. You have to log into each cluster. You have to log into each cluster, and then be like, okay, I need to do a deployment here. What's the point, right? So that's where this thing comes. But of course, it comes with an overhead. As I said, everything is a trade-off. You have to run an extra cluster. All these clusters, you have to figure that stuff out.
I love it, but I think if I had to go back to VMs, I would quickly be like, oh, let me go back to containers much faster.
Yeah, honestly, that's what will happen. That's what will happen.
All right. So we've got one. Does the vCluster does the vCluster sync result in some latency? For example, let's say I have an application is required
Okay.
to scale the pods with that result in latency or some sort of delay. So I guess you have to say there is some delay, right? But it's not going to be a delay. I think that you notice, like I'm talking about like probably milliseconds, something like that, because you still have to
Yeah,
create the
yeah,
resource through this API. So you're still doing an API request, right? So your API requesting above the base API into this other cluster, and the stuff's getting created there. But as soon as Kubernetes sees that, it starts creating it. So
yeah.
in terms of like how much time, like say I'm using Knative or something, how much time would this add for me to scale up and scale down? I don't think it's, maybe it's noticeable over like long enough or large enough like a deployment, but I don't. We have some tests and stuff that are going in vCluster for scaling to show like the
Hmm.
time stuff. But I can't give you a time of like what is the latency. I'll say if you add another API above it, you're gonna have some latency, but I don't think it'll
Yeah,
be
I
that
mean,
noticeable. Yeah,
the thing is, nothing's for free, right? You have to look
yeah,
at the trade-offs. What do you get in? Maybe you have a few milliseconds, but you get something which might be worth those few milliseconds, right? Because you
yeah.
have like a cluster that you can share with more confidence than you could previously. So yeah, everything has that's very well
Is there
answered there,
latency?
Mike.
I say, is there latency for reconciliation? Well, it's the base cluster is going to reconcile it. So however long it takes for that. So the only time you're adding, I think, latency on top of it is the initial API request and getting that synced in, or getting that applied to the virtual cluster. But then it should be just as fast. Okay, so if you change resource in your hosted cluster and it needs to sync, um, I mean, just as fast as I guess Kubernetes is able to do it.
Yeah,
Uh, I think we give more information on Slack after, but yeah, I think I know where you're going. Like, how much time is this going to add? All right, let me go to the next one real quick.
yeah.
So, what are your experiences using single ingress controller for the base cluster, controlling subclavier controllers? Any solution for enterprise scale workload? So, single ingress controller on the base cluster versus controlling subcluster traffic. So we had some kind of answers on that previously, where it's
Yeah.
depends on what you need, right? Like if you have a lot, if your users need very specific things configured in ingress or have flags that they want on, then maybe you're going to have multiple ingress controllers, but it's going to cost you more because you're going to have more load balancers. Versus if you could just have, well, let me let you answer. I've been answering. You might have
No, 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 no. You,
information.
you carry on.
Okay.
You carry on with your thought
Okay.
because that's absolutely correct. Carry on.
So yeah, if you can have one ingress controller on the base cluster and share it up, especially if it's like dev and not or if it's dev or test or something like that, and you don't really have a huge need for it, then I would say go to single ingress. But if you have users that are like, hey, I need this, I need this, I need this every time, and you don't want to manage that on the ingress controller you're using, then you can give them the ability to add their own ingress controllers, and then
My
they got to
yeah,
pay for the load balancer.
my answer is less way simpler than yours, Mike.
Yeah,
But hopefully it means the same. I always go for less is more. The
yeah,
fewer things I have around the cluster, the easier it is, right? But again, as you said, Mike is absolutely right. Maybe you have a use case. Maybe somebody asked for something very specific. Oh, I want the sticky session that only comes with traffic. I don't know. Then you might have to think about bringing that in. Absolutely correct. But I would try and be like, no, there's just one because otherwise you have to manage it, right? It's this.
yeah.
But again, use cases. Everything has use case.
All right, I think we got one more. So, what is the
One
exact
more.
use case of vCluster in Kubernetes? They missed that in the last meeting. So it's the main use case I think when it came in before is multi-tenancy. Like if you want to give vCluster like a single word, what does it do? Multi-tenancy. So it gives you the
Hmm.
ability to split up a cluster into multiple different clusters and give people access to that. So you can have 50 developers on the same cluster and they may not realize they're on the same cluster. Whereas
Yeah.
before, like they would see like all the namespaces, they'd be restricted to namespaces. But for them, they just see, oh, I can create my own namespaces. I can do all these things. I think they're admin. So
Yeah.
multi-tenancy is a big one. Isolation, saving money. Like costs, I guess, is like a big one too.
You
Like if we want to say
should have
start
started
with
with that one.
costs,
Saving
yeah,
money.
yeah, saving money, right? Because in time, right? Like so time too. So you save time. So vCluster comes up a little bit faster, not a little bit, but a lot faster than some of the
Yeah, it's like that.
like cloud providers, like full Kubernetes clusters, right? So if you just need a quick cluster to test something, like you've got like a pull request you need to test, like this is a good use case. If you have a developer who just needs Kubernetes to work for like a week, give them a virtual cluster, and then you can always delete it too. So ephemeral or production, whichever one you want. So that's kind of the main use case, I would say, multi-tenancy.
Yeah, and
If you're
if
that.
people haven't, yeah, I completely agree with that. And all the stuff that I was mentioning in the beginning, or if you don't go with this, or there's all these bits you have to think about, namespaces and network policies, all of that stuff comes with it. And if people have any more questions, I know we're coming to an end. Please do hop on the Slack. I think your user Slack is quite good, the Loft user Slack, and I'm on there as well. If you have any questions, throw them on there, and I'll try and answer them. Mike is there, and others are there, so we can answer them there.
Yep. Awesome. I think we got basically all the questions on there. If yeah, like I said, if you already done my job for me. If you have more questions, come check them out there. And I'll say Thank you so much. Thank you so much for the presentation. It was
Well,
awesome,
thank
and
you.
thanks everyone for joining us. I don't know if you have any parting words or.
Yeah, well, choose the pill wisely. That's what I would say. But no, thanks everybody for joining. Really appreciate that. I know it's quite early for some of you and quite late for some of you. And thank you, Mike and Rahul, for hosting us. It's a great webinar. Please do sign in for the next week's one. To
Yep.
Chris, it's going to be an interesting one. All right, thank you all.
Yep. And we'll send out additional communication that you'll receive with an email with the video in case you missed anything, you want to rewatch it or see any of the parts that you missed. But
All right,
thanks
appreciate it,
everybody.
people. Thank you.
See y'all
Bye.
next week.